Hi. So in this module, we're going to be talking about the flow of energy through trophic systems, through trophic networks, and discuss what the implications are of how energy flows through these systems on our behavior and how we consume our forms of energy. So what is energy? Energy is very universally the capacity to cause change. It exists in many forms. For our purposes, in our studies of ecosystems and ecology, we're going to think about energy very simply as something like the energy that we consume. So we are familiar with calories. Hopefully most of you have spent some time thinking about calories, and we can think about energy in that form. So how much energy is in the food we consume, and how much energy it took to get there, to get the number of calories that we are consuming. Here are some other forms of energy that you've probably been familiarized with in other classes, for example, potential energy or kinetic energy. And for our purposes, so muscle movement, right? So running, just being alive, keeping our body warm, that requires a lot of molecular energy, right? Biological energy. And we gain that energy by eating things. There are two laws of thermodynamics that are really important for our understanding of physics and chemistry, reactions, and for our purposes, our understanding of how energy flows through an ecosystem. And these two laws of thermodynamics will teach us why energy moves the way it does through an ecosystem. So thermodynamics is the study of energy transformations. And when you are consuming something, when you eat a cupcake, you are transforming the energy that's in that cupcake, the fat and the sugar that's in that cupcake, and you're using it to heat your body and to move and to generally be alive. So that's a transformation of energy. What do we know about transformations of energy, such as the example I just gave? We can consider Earth a closed system. So Earth is like a thermos. We do receive solar energy from the sun, so energy comes into Earth. However, matter is not moving in and out of our atmosphere, right? Pretty much whatever the molecules are on Earth are the ones that we've always had here, which is kind of an interesting concept if you think about it. So Earth is a closed system. In an open system, energy and matter can be transferred between the system and its surroundings, but Earth just receives some solar energy and does not exchange matter at all. Therefore, it is closed. Organisms, such as yourself, are open systems. So you receive energy and matter, and you excrete matter as well. So I mentioned that there are two laws. The first law of thermodynamics is that the energy in the universe is constant. So energy can be transferred and transformed, but it cannot be created or destroyed. This principle is known as the principle of conservation of energy. That is law number one, and we're going to discuss that in great detail. During every energy or transformation, some energy is unusable and is often lost as heat. And that is what the second law of thermodynamics tells us, that every time you change energy from one form to another, so when you eat that cupcake and you break it down, so that let's say the cupcake has 500 calories, you do not get 500 calories of usable work from that cupcake. You can use just the process of breaking down the fats and the sugar in the cupcake are going to create heat, and you're going to lose not a lot, but you're going to lose some of that energy to heat. So your body will not be able to harvest 500 calories from a cupcake when you eat it. Maybe that's a good thing. So the second law of thermodynamics states that every energy transfer or transformation will increase the entropy of the universe, and we'll use the word entropy a few times. When you think about entropy, just think disorder. So when we break down the molecular bonds in a cupcake, we are in fact contributing to an increase in the disorder of the energy that was in that cupcake. So it is no longer ordered, and we've broken down a lot of those bonds. A lot of that energy has been lost to heat, and therefore we've increased the entropy of the universe. just by eating a cupcake. Here are examples of the first law and the second law of thermodynamics. It's similar to the example I've been giving you with the cupcake. So here's a cheetah eating some meat. So the cheetah is acquiring chemical energy, right, through the meat, and it's using that energy, those calories, to run around just through the process of living, of respiration, keeping its body warm, and other processes. A lot of that energy is being used up, and every time there's a metabolic reaction, part of that energy, so there are bonds being broken, chemical bonds being broken, and some of that energy is going to escape through heat. And that's actually one way that we do heat our bodies. The laws of physics and chemistry, so the thermodynamic laws that we just went over, apply to ecosystems. Application we're especially interested in is energy flow. The first law of thermodynamics states, as like we said, that energy cannot be created or destroyed, only transformed from one form to another. We receive energy into our Earth, into our ecosystem, as solar radiation from the sun, and that energy is transformed by plants into matter. So plants take sunlight and convert that to an actual physical matter. So that energy is conserved, and as other animals eat the plants that have captured that solar radiation, those molecular bonds will be broken, and that's the second law of thermodynamics. We're going to lose some energy as heat and contribute to the disorder of the universe. The second law of thermodynamics states that every exchange of energy increases the entropy of the universe. So here's a diagram of the transformation of energy that we've been talking about. Here's the solar energy coming from the sun that is feeding the plants. Plants are harvesting that energy, and they use very beautiful and complex systems to capture those photons and actually convert CO2 from the air into organic matter. So when we talk about organic matter, we are referencing carbon-based material, right? Carbon-based living material. And so plants are taking CO2 and converting that into sugars and other elements, other material that plants are made out of. So plants are primary producers. Here are the producers. Next come herbivores. So that's a cow who's going to eat grass. Cows are going to eat the grass. They're going to break down those molecular bonds. Some of that energy is going to be lost as heat, right? Second law of thermodynamics. And some of that energy is going to go into the cow and contribute to it growing big and strong and heating itself and reproducing and everything that life, all the energy that life requires. Carnivores come next, right? They'll eat the herbivores, and then top carnivores come next, and we'll talk about this trophic pyramid in detail soon. Here is a idealized cartoon of the flow of energy through our trophic system. So much like the cartoon we just saw, where sunlight, we receive energy into our ecosystem from the sun. Plants capture that sunlight and turn that energy into matter, into material, right? So plants are taking energy and converting it into something that you can actually hold. Plants are known as primary producers. This is going to be an important term for you to remember, and I encourage you to take a moment and think about those words and find a way to remember them. Primary consumers are the first line of herbivores that eat plants. So primary producers produce material, primary consumers consume material. Secondary consumers are going to be consuming our primary consumers. Tertiary consumers are the very top of the pyramid, that bird of prey that we saw in the last diagram. An important element of this whole cycle is decay. Plants die, right? Cows die, secondary consumers die, tertiary consumers die, and all of that matter needs to be recycled by microorganisms, bacteria, yeast, worms that degrade that material and turn it back into a form of carbon and other elements that can be recycled back into the ecosystem. Importantly, we see on every step, every transformation of energy from one step to another, we lose heat. So not all of that energy that the primary consumers are eating is being used to build the bodies of the primary consumers. Because of that inefficient transfer of energy, energy is being lost every time there's a transformation of energy, seen here. This is a summary of all of the terminology that I would like you to remember. So autotrophs, troph means to consume or to eat. Autotrophs mean they make their own food, so plants are autotrophs. They build molecules themselves using photosynthesis. So photosynthesis is the process of capturing sunlight and transforming it into matter. Chemosynthesis is another method of transforming energy and turning it into matter. We're not going to discuss that very much, but it also exists. So photosynthesis uses light as the energy source. Heterotrophs do not create their own food, so primary consumers, secondary consumers, these are all heterotrophs. They depend on the biosynthetic output of the primary producers. Energy and nutrients pass from primary producers to primary consumers to secondary consumers and tertiary consumers. And what's interesting is that because we lose energy every step of the way, so because of this loss of energy at every step of the pyramid tends not to be very tall. It's usually about 4 levels high, maybe 5, but there is actually an upper limit of how many steps in our food pyramid we are able to have on Earth here.